supplement to the Wizard of Odds Blackjack Strategy and House Edge spreadsheet for infinite decks with rule variations. The Wizard of Odds, Michael Shackleford, has done something really impressive and amazing. He calculates the Blackjack Basic Strategy and House Edge from scratch in less than 1 hour. He does it live in a YouTube video using an Excel spreadsheet. His video is targeted for viewers who understand the fine points of blackjack, who understand math and probability, and understand how to use spreadsheets. Now, you may not necessarily meet all these qualifications, but you still want to understand his spreadsheet. If that's the case, that's the purpose of this video. So my video, the one you're watching now, is a supplement to the Wizards video. I explained how to modify the spreadsheet for the following rule variations: no surrender available, dealer hits soft 17, and blackjack pays 6 to 5. I also explain in simpler terms than the Wizard how his spreadsheet works. I also explain some terms you may not be familiar with: infinite decks, European whole card rule, and the magic step that fills in a whole table of data starting at the 5.5 minute mark in the Wizards video. If you're like me, you have trouble following that part. I had to stop the video, examine the spreadsheet, and figure out what he was talking about. And I'll explain what I learned. What you need to do is first watch the Wizard's videos. He has 2 videos, one on the basic strategy. He starts with a totally blank spreadsheet and explains step by step how to calculate the full basic strategy. And then he has a second video, a shorter one, that he calculates the house edge using the data from the first video. So watch the 2 videos. If you understand everything you see, you have no need for my video. You can skip mine. But if you didn't understand everything, or you reach a point where you can't follow it, stop watching that video. Come back and watch mine. And after you watch mine, go back to his video, and hopefully you'll be able to complete the Wizard's video and understand everything in it. And you'll need to download the Wizard's Excel spreadsheet using the link provided in his basic strategy video. If you have problems downloading the spreadsheet, it could be you're using a browser that's too old. Try using a different browser or updating your existing browser. So after you download the spreadsheet, you'll see it, and you open it in Excel, and you'll see this bunch of tables with numbers. If you follow the Wizard's explanation, you understand everything. But if you didn't, let's take a look at some of the things in the spreadsheet. The last one, the EV spreadsheet, I'll click the little tab that says EV at the bottom. This has the final calculation of the house edge, or expected value. This cell here, which says grand total next to it, tells you your total expected value on a $1 bet. Let's copy that. I'll select it by clicking on it. I'll do Control-C to copy, and I'll paste it down here. When I paste, I'm not going to paste the formula, I'm going to paste the number. So we go up to the paste menu. You see different ways of pasting the value. I want to paste it as a number. The reason I want to do that is I don't want this to be updated later when we modify the spreadsheet. This will stay fixed at this number, whereas this cell will get updated automatically when we modify the spreadsheet. Now I'll put a label here so we remember what this is. This is expected value, EV. Another thing I like to do is change this from a decimal to a percent. So I go up to this percent sign up here, I click, and it becomes a percent instead of a decimal. And I want to increase the precision to show 2 decimal places or the nearest hundredth of 1%. So you can see that with the blackjack rules being analyzed now, your expected return is about minus half of 1%. So on a $100 bet, for example, your average loss will be 48 cents. All right, now we'll take a look at the surrender option. If you click the HSDR tab, that's hit, stand, double, surrender, you see the calculated basic strategy. This should look familiar with anyone who's studied blackjack. This is your hand, this is what the dealer has, and these are the best decisions. The surrender bet, or surrender option rather, allows you to surrender half of your bet after the card's been dealt out, and you see your 2 cards and the dealer's up card. If you don't like what you have, you can forfeit half your bet rather than play out the hand. That's only worthwhile in a very few situations, 16 against 9, 10, or ace, or 15 against a 10. Click the SUR tab. This is the part of the spreadsheet that sets your return for this option. You lose half a bet if you surrender. Now if we pretend that you lose all of your bet when you surrender, that is a -1 instead of a -0.5. That's the same as not offering surrender. You would never surrender if you have to forfeit your whole bet. It would be always better to play out your hand. So let's do that. We put a 1 here. You manually type in a -1, and you can see there's a black box with a little dot in the corner. If you drag that dot over some cells, it'll copy the value from the first cell into the other cells. So I can very quickly replace all the -0.5 with -1s. And we can immediately see the effect of this change in the HSDR spreadsheet. You can see the surrender option is no longer shown because it's not an acceptable. It's not the best decision. It's always the worst decision. Now, how does losing the surrender option affect your expected value? Let's take a look. We've got a new value here as a grand total. Let's copy that and paste it down below as we did before. I click on it to select, Control C to copy. I'm going to paste it here as a value. I can right click and do paste number, and once again we'll display it as a percent with 2 decimal places after the 2 numbers after the decimal point, and let me label this EV, no surrender, no surrender. Now what is the change from here to here? I'll put that in this cell. The change is the new expected value minus the old expected value. To make a formula like that, just type an equal sign. Equal sign means it's a formula. It's the value in this cell. I type a minus sign. The value in this cell. Press return, and it shows the expected value got worse by 0.09%, or about 1/10 of 1%. So instead of on a $100 bet, instead of losing 48 cents, you lose 57 cents on average. Okay, now let's take a look at the rule dealer stands on soft 17. In most casinos, dealer hits soft 17. Let's modify the spreadsheet and see how it affects the game. Go to the leftmost tab, click where it says dealer, and this table shows the probability of the dealer achieving any particular final hand given the dealer's current total. If we scroll over to the right, we see the label soft. This part of the table shows the probability of achieving various final outcomes for the dealer. Now, the dealer has soft 17. If the rule is the dealer stands on soft 17, there is a 100% chance the dealer end up with 17, and a 0% chance of the dealer ending up with 16, 18, 19, busting, or getting something higher, 18, 19, 20, or 21. If a dealer hits soft 17, we expect to see some different numbers in this column. Now, it turns out it's quite easy to do this. All we have to do is copy the formulas from the column on the left into this column, and we get exactly the result we want. To copy the formulas, you can select this cell by clicking on it, but don't drag that. Don't drag that because that will copy the value. That's not what we want. We hold on the Shift key and click on the bottom one. We've just selected this block of formulas. So I can type Control-C to copy. Click here to select the next column. I type Control-V and I want to paste that whole column in there. Now we got the result that we want. When the dealer has soft 17, there's a 34% chance he'll end up with a 17, 21% chance of busting, and 11% chance of getting 18, 19, 20, or 21. How does that affect the strategy? We'll click the HSDR tab, and everything's pretty much the same except right here. If you get an 11 and the dealer has an ace, you would double instead of hit. I suppose that's because the dealer is more likely to bust. It just barely makes it more profitable to double rather than hit on 11 against ace. Let's see how it affects our total return. The grand total return is now negative 0.00789. Let's select that. Control-C to copy. Click down here. Paste as a number. I will make that a percent, 2 decimal places. I'll label this expected value, no surrender, and dealer hits soft 17. Now what's the change from here to here? Let's type equals the value of this cell. Type the minus key, the value in this cell, press enter. A dealer hitting soft 17 has a cost of 0.22%, or 22 cents on a $100 bet. Our expected value, or house edge, is 0.79%, and that's still less than 1%. About 79 cents for a $100 bet. More and more games these days are paying 6 to 5 on blackjack instead of 3 to 2. In other words, on a $10 bet, when you get blackjack, instead of winning $15, you only win $12. Let's see how the game is affected by it if we change the blackjack payout. Where is that done? Oh, here we go. ER, expected return. If we click that tab, we see that if you have soft 21 or blackjack, your return is 1.5. 1.5 times your original bet. Let's change that to 1.2 for 6 to 5 blackjack. Copy that value across the table. Okay, the strategy is the same. You have the same decisions as before. Let's take a look at the expected value. The house edge is now 2.1%. Let's copy that. Control C. I'll paste it down here as a number. I'll make that display it as a percent with 2 decimal places, and I'll label this EV, no surrender, double down. Dealer hits soft 17 and 6 to 5. Doesn't quite fit. Let me make that bigger. How much did the 6 to 5 payout cost? It's equal this cell, type minus the value in this cell, press enter. The 6 to 5 rule costs 1.35%. So the moral of this exercise is never play any game that pays only 6 to 5 on blackjack, because you'll lose money about 3 times faster than any game that pays 3 to 2. Okay, I'm going to explain a couple of things that you may not be familiar with. First of all, the wizard's strategy is for infinite decks. What does that mean? That's the mathematician's way of saying we're ignoring the cards that have been played out, have already been dealt out, and consider all cards 2 through 10 and Jack, King, Queen, Ace as all being equally likely to be dealt out at any given time. Why is it called infinite decks? Well, if you're playing from one deck, for example, and 2 aces are dealt out, half of the aces are gone from the deck, and aces are half as likely to be dealt out as normal. Whereas in, say, an 8-deck game, if 2 aces are dealt out, only, 1/16 of the cards have been dealt out, and 15/16 remain, and aces are almost as likely to be dealt out as anything else. So you can imagine if you had, say, 1,000 decks or an infinite number of decks, it would make no difference at all how many have been dealt out. Ace would be, all cards have a 1/13th chance of being dealt out at any given time. Now, what is the European whole card rule? Well, in Europe, the dealer doesn't check his whole card, that is his second hidden card, until everybody's played out their hand. And so what difference does that make? It makes only one difference. If the dealer has blackjack and you've split or doubled, you lose all of your additional bets. Whereas in American blackjack, you can only lose your original bet when the dealer has blackjack. So that affects the strategy, because when you're playing in Europe, you'll be less likely to double or split because you don't want to put more money at risk in case the dealer has blackjack. So you'll see in the Wizards dealer probabilities. We have this lower table is playing according to the European whole card rule, where you don't find out until the end whether the dealer has blackjack. And this table up here is the part where you assume the dealer does not have blackjack because the dealer has checked and confirmed that he doesn't have blackjack. So you see different numbers here in certain cases. When the dealer has a 10 or an ace, these numbers are different because the dealer for certain doesn't have a blackjack. The numbers in these columns are the same between the top and the bottom. Okay, now we reach the most challenging part of this video presentation. The magic step at the 5.5 minute mark in the wizard's first video, where he copies one formula and fills the whole table. How does that work? That confused me. I had to stop the video and examine the spreadsheet to understand it. Let's take a look. I think the wizard started at this cell right here. He wrote the formula for this cell and then copied it and filled this whole table. I think it's easier to understand if we start over here on the right side. If you recall, from the wizard's presentation, this row is the dealer's total, current total, and the numbers below total the probability that given that dealer total, whether that total end up busting or ending up at 17, 18, 19, 20, or 21. If the dealer has 17, then the probability that the dealer will end with 17, this is a hard 17, is exactly 1. And the probability of getting any other total is 0. So these are all zeros here. 0, 0. These are all zeros. Now what if the dealer has 16? What is the probability that the dealer will bust and end up with a 17 and so on? For hard 16, that's pretty easy to calculate because the total will be decided on the very next hit card. Before we talk about this, let me change this this soft 17 back to what it was before. If you recall, if the dealer has soft 17 and the dealer stands on soft 17, the probability of busting is 0, which I will copy throughout this column, and the probability of getting a 17 is 1. Okay, well now we're back to the dealer stand on soft 17 game. Go back here. Okay. If dealer is 16, hard 16, what is the probability that the dealer will end up with a 17? That's easy. The answer is 1/13 because 1/13 of the cards are aces. The dealer hits 16 and gets an ace, will end up with 17. If you get out your calculator, you see that 0.07692 is the same as 1/13. Similarly, if the dealer gets 2, the dealer will end up with 18. That's also a 1/13 chance. And similarly for getting hit with a 3, or 4, or 5. Dealer gets hit with a 5, dealer ends up with a 21. They'll have a 1/13 chance. So there's a 1, 2, 3, 4, 5/13 chance of getting a good total for the dealer. And the remaining cards having a probability altogether of 8/13 has a 61% chance of busting. That means getting a 6 or higher. Okay, that's easy enough for hard 16. What about hard 15? For example, for hard 15, the number in this cell has the probability that the dealer will end up with 17. How is that calculated? We do that by considering each of the possible hit cards and the probability of ending up with 17 for each of those hit cards. In this case, for example, if you hit hard 15, there's a 1/13th chance of getting a 2. A 2 will bring your total up to 17. This cell, over 2 columns over, tells the probability of ending up with 17. When you have 17, that probability is 1. So the probability of getting a 2 is 1/13th. So the probability of getting a 2 and ending up with a 17 is 1/13th of the value in the cell. To that, we have to add 1/13th of the value of this cell, because there's a 1/13th chance of getting a 3. When you hit 15 with a 3, you end up with 18. The probability of ending up with 17 when they do that is 18 is 0. So it's 1/13th of 0. Similarly, 1/13th of 0 here, 1/13th of 0 here. And when you get to the 10, there are 4 different 10 value cards: a 10, Jack, King, and Queen. So there's 4/13th chance of getting a 10 value card. And 10 plus 16 is 26. That's a bust. The probability of ending up with a 17 is 0. So it's 4/13 times 0. And finally, there might be an ace. For an ace, you end up with soft 17, not hard 17. So you have to go way over in this column and add 1/13 of this value. Okay, so what does that formula look like? If we click on here and look up here, we have the formula for this cell. It's the sum of what's in cell Q12. That's this one, right? That's where you hit with a 2, you get this one, through X12. So 1/13th the value in this cell, 1/13th the value in this cell, 1/13th the value in this cell, 4/13 times the value in the whatever it was, to hit 10, 15, 25. Did I say 26 last time? I meant 25. And 1/13 times the value in this cell. Once again, that formula is he divides by 13 at the end instead of each one. So the value in this cell plus the value in this cell plus the value in this cell plus 4 times the value in the 10 hit with a 10 cell plus 1 times the value in the value in the cell way over in the soft hit column. Okay, so basically it's the same formula in every cell here. We look at the one below, for example. It's Q13 through X13 plus 1 times AU13, and so on. So when you copy a formula from one cell to another, the copy is relative. It looks to the right by a certain number of cells. So it maintains geometrically the same relationship. So the wizard starts with this cell, I think, here. And he says equals, and then he types sum, and then he selects these cells, the 2 through 9, 4 times the cell that's 10 hit card, and 1 times the soft total hitting an ace, divided all by 13 at the end instead of the beginning. So that's basically the magic formula. He enters the formula, he copies that formula to this whole table, and voila, the whole table is filled with values that are correct. So that's the magic step that instantly fills the whole table. And if you can understand how that step works, you can probably figure out the rest of the whole blackjack spreadsheet. So that was the magic step that fills the whole table, from the 5.5 to the 6.5 minute mark in the wizard's video. So I hope that helps you understand everything. Good luck, and may you win your next gambling session.